Good morning, class. Today we will discuss exercise 6.3 of square and square roots. Okay, so the first question, which could be the possible ones digit of the square root of each of the following numbers? Now the first is 9801. Now we have to find that if we have to find the square root of 9801, then what will be the digit at the units place? Now in order to find the digit at the unit place, we have to find a number the square of which contains 1 at the unit place. We know that the number whose square is having 1 at the unit place is either 9 or 1, because the square of 9 is 81, so it will have 1 at the unit place, and the square of 1 is also 1, so it will have 1 at the unit place. So the number 9801, the square root of this number will contain either 9 or 1 in the unit place. The second part is 99856. If I have to find the square root of 99856, then what will be the digit at the unit place? We know that the number 4 and 6, if we do the square of 4 and 6, the square of 4 is 16 and the square of 6 is 36. So both of them are having 6 at the unit place. So this number, the square root of this number will contain either 4 or 6 at the unit place. So the third part, I have to find that if I carry out the square root of 998001, then what will be the digit at the unit place? Now again, I am having 1 at the unit place, so I have to find a number the square of which will contain 1 at the unit place. So either it will be 9 or 1. If I have to do the square of 9, it will be 81. So it will have 1 at the unit place, and the square of 1 is also 1, so it will have 1 at the unit place. So it will have either 9 or 1 at the unit place. Fourth part, 657666025. If I have to find the square root of this number is having 5 at the unit place. So I have to find a number whose square will contain 5 at the unit place. So the only number is 5. The square of 5 is 25. So the unit place will be 5. Okay, the next question, second question. Without doing any calculation, find the numbers which are surely not a perfect square. We all know the property of perfect square, that the number ending with 2, 3, 7 or 8 is never a perfect square. So if I see the first part, this number is ending with 3, 153. So this will never be a perfect square. Second number 257, this number is ending with 7. So again, this will never be a perfect square. And the third part 408, again this number is ending with 8. So this will never be a perfect square. Now fourth part 441, now it is ending with 1. So I can say that it can be a perfect square or it cannot be a perfect square. So without doing calculation, I can say that first part, second part and third part can never be a perfect square because they are ending with 3, 7 and 8. So the property, I can say that 1, 2nd and 3rd can never be a perfect square. Okay, third question. The third question, I have to find the square root of 100 and 169 by repeated subtraction. Now, first of all, what is the meaning of repeated subtraction? We have to subtract the odd numbers from the given number until we obtain 0. Now, first of all, I have to find the square root of 100. So, what I can do is, I will subtract 100 minus the first odd number, that is 1. I will get 99. 99 minus the second odd number, that is 3. I will get 96. 96 minus the third odd number, that is 5, that is 91. Again 91 minus next odd number, 91 minus 7, that is 84. Again 84 minus the next odd number, that is 9. 84 minus 9, that is 75. 75 minus the next odd number, that is 11. I will get 64. Now 64 minus the next odd number, that is 13. I will get 51. Now 51 minus the next odd number, that is 15. It will be equal to 36. 36 minus the next odd number, that is 17. I will obtain 19. And lastly 19 minus the next odd number, that is 19. It will be equal to 0. So now I have obtained 0. I will count the number of steps required to obtain 0. If I count the number of steps, I will get the number of steps to obtain 0 is equal to 10. So I can say the square root of 100 is equal to the number of steps required, that is equal to 10. In the same way, I can carry out the square root of 169 by the successive subtraction method. Okay, next question. Fourth question. Find the square root of the following numbers by prime factorization method. Now the first part, 729, I have to find the square root of 729 by prime factorization method. Now square root of 729, firstly the prime factor 3, 3 2s are 6, 3 4s are 12 and 3 3s are 9. Again with 3, 3 8s are 24 and 3 1s are 3. Again I can divide it by 3, 3 2s are 3, 8, 3 7s are 21. Again with 3, 3 9s are 27. Again with 3, 3 3s are 9. And lastly with 3, 3 1s are 3. Now what I can do is I can write 729 as under root of 3 into 3 into 3 into 3 into 3 into 3. Now what I have to do is I have to do the pairing. 3 into 3 the first pair, 3 into 3 the other pair and 3 into 3 the third pair. Now I can take each factor out from this pair. So the number will be 3 into 3 into 3, that is equal to 27. So the square root of 729 is 27. Similarly, I can get the square root of